Hello, this is John Hearn, and I'm going to look at this Physical Science Module 1 worksheet, where we're going to look at just some example conversions, some example significant figures, and then scientific notation. So first on the conversions, so convert 432 grams to kilograms. So remember that when we want to convert from one unit to another, we start by writing down what the given quantity is, and that's 432 grams. And then we're going to draw a horizontal line. This is a big division line. And then we're going to draw a vertical line. This says I'm going to multiply across here, and then I'm going to divide everything down here. Then we want to put grams in the denominator and kilograms in the numerator so that the grams will cancel. And then when you look on your conversion factor sheet, you'll see that 1 kilogram is 1,000 grams. Your conversion sheet may say 1E3. That's 1 times 10 to the third, and we'll go over some example scientific notation at the bottom. But 1 times 10 to the third is 1,000. So before I punch anything into my calculator, I want to check the units. My grams cancel, and I'm going to be left with kilograms, which is what the problem asks for. So I'm going to take my calculator, and then we're going to punch in 432. Okay, so there's, oops, let me turn it on. Okay, 432. And then we're going to divide it. So we don't need to multiply by 1. So remember, that's just, we can multiply by 1, but there's no need to put that in the calculator. I want to divide by, and then you can either type in 1,000 like this, hit enter, or 432 divided by, you can use the scientific notation where you say 1 and then you want the EE button. Only one E is displayed in the calculator, but it's the EE button. And then 3, and then hit enter. And it gives you the same answer, so you can put it in either way to get to the 430, or to get to the answer, which is 0.432 kilograms. Okay. All right, so for the next one, I want to convert 0.35 liters to milliliters. So let me write down 0.35 liters. And then I want here to write out my conversions. I want to go from liters to milliliters. So I'm going to put liters down here, milliliters up there. Now, a lot of folks remember that there are 1,000 milliliters in 1 liter. So you could write 1,000 up here and 1 down here. But on your conversion sheet, you'll see that the definition is that 1 milliliter is 1E minus 3 liters. Okay, so you can write it either way. I'll show you that this all works out. And just before we do anything on our calculator, we want to check our units. My liters cancel, and I'm left with milliliters, which is what the problem statement asks for. And when I go over here to my calculator, I'm going to punch in 0.35, and then I want to divide that by 1E, and then I want to put minus 3. Now, on your calculator, you need to use this button right here for the minus, because you're putting a sign on the number. This is a -3, not a subtraction symbol, right? So this is the subtraction button. This is the sign button. So here I'm going to push this button right here to get the negative sign, and then push in 3, and then hit enter, and that gives me 350. All right, now notice, oops, if I take 0.35 and I divide it by 1E, and then I decide, I want to use this minus button. Notice that the character that the calculator displays is different, right? So this is a subtraction symbol, and I put in 3, it's going to give me a syntax error. That's because you can't use that character when you are writing this out. You have to use the minus, okay? So it's 350. All right, I'm going to go over here. I'm going to write down 350 milliliters. All right, now just to show you, we could have also multiplied this by 1,000 because there are 1,000 milliliters in 1 liter and got the same answer. All right, so multiplying by the 1,000 is mathematically equivalent to dividing by 1,000th. Okay, so you can put either into your calculator. All right, the next one, 3.5 cups to quarts. So let me write down 3.5 cups. I want to put cups in the denominator, quarts in the numerator, okay, because I want my cups to cancel. And then I want to put in my conversion factor. 1 quart has 4 cups. Before I do anything on my calculator, I'm going to check and make sure that my units cancel, my cups cancel, and I get quarts, which is what the problem statement asks for. And then I will put that into my calculator. 3.5 divided by 4, and it's 0.875. Technically, we can't increase the number of significant figures beyond what we had to start with. There are 2 significant figures here. So I would want to report this to 2 significant figures. So I would round. A lot of times you'll see the rule is if it's 5, round up. Sometimes you'll see if it's 5, round to the even number, but we'll just round up. So this is 0.88 quarts. So you'd want to say that there are 0.88 quarts, not 0.875 quarts. Okay. Next, convert 8,739 feet to miles. Let's write down 8,739 feet. And then over here, I want to put feet on the denominator and then miles in the numerator. And then I want to put in my conversion factor, which is 1 mile is 5,280 feet. Okay, and then I'm going to punch that into my calculator. 8,739 feet divided by 5,280, and I get 1.655 miles. Notice that I'm going to write down 4 significant figures because I started with 4. All right. These next 4 problems, how many significant figures are in the following measurements? Okay, so remember non-zero numbers are significant, so this 3 and that 5 are both significant. The question is the zeros. Remember, zeros that are to the right of the decimal and to the right of a significant figure are significant. So these are not significant. This one is significant. So all 3 of these numbers are significant. So this one has 3 significant figures. Okay. The next one, I have a 1 at the beginning of the number and a 1 at the end of the number. So everything in between has to be significant. So I have 1, 2, 3, 4, 5 significant figures. Okay, here I have a 2 and a 2 based on our rules. This 0 that's between these significant figures is significant. The question is, what about these trailing zeros? Well, these 2 zeros are to the right of a significant figure, but they're to the left of the decimal. Now, the decimal is not displayed here, but it's implied to be at this location. So these 2 zeros are to the left of the decimal, but to the right of a significant figure, so they are not significant. So this number has 1, 2, 3 significant figures. Okay, this last one, I have a 1 and a 2. Those are significant. These 2 zeros that are in between significant figures are significant. So this 0, the question is that one significant? This 0 is to the right of the decimal, and it's to the right of a significant figure, so it is significant. So this one has 5 significant figures. All right, this last is just a little bit of practice in writing measurements in scientific notation. So remember, with scientific notation, we're looking to move the decimal to the location after the first non-zero number. So we want to take the decimal here and move it 3 spaces to the left so that I have 4.352. So this is going to be 4.352. Okay, so I'm going to go ahead and write that out. And the question is, how do I get the decimal back to where it started? Okay, so when I look at this, what do I need to multiply this by to get 4,352? Well, I need to multiply it by 1, 2, 3, which is 1,000, or E3 meters, right? So remember, the E says times 10 raised to the 3rd power. So this tells me I would take the decimal and move it 1, 2, 3 spaces to the right to get this. All right, the next one, I can go ahead and write out the number 3.15. Remember, when we're working in scientific notation, we're typically moving the decimal to the location right after the first non-zero digit. And the question is, how do I regenerate this number? Well, I need to move the decimal 1, 2, 3, 4 spaces to the left. Okay, so I'm going to say E minus 4, kilograms. Right? So notice that the -4 tells me I'm going to take the 3.15 and move the decimal 1, 2, 3, 4 spaces to the left to get back the standard notation. All right, last one. I can go ahead and write down 9.3. Okay, and then we just need to count. How many do we have? 1, 2, 3, 4, 5, 6, 7. 9.3 E7 liters. So notice if I take the decimal, this positive 7 tells me I'm going to move it 7 spaces to the right to regenerate this. All right, so when we're writing, going from scientific notation to standard notation, it's probably a little bit simpler because we're just sort of following the mathematical instructions that are right here. We have the number 4.02, and this E5 tells me I'm going to move the decimal space 5 places to the right. So I'm going to write 402, so that's 1, 2, 3, 4, 5. Okay, so notice it was here, and then it goes 1, 2, 3, 4, 5 spaces to the right. All right, this one here, 5.90 times 10 to the -3. I want to move the decimal 3 spaces to the left. So I'm going to start with a 0.00590 liters. Notice that I started with the decimal here. I had to move it 1, 2, 3 spaces to the left, which is where it is. 1.23 times 10 to the 6 meters. Again, I'm going to take 1, and I'm going to move the decimal 6 spaces to the right. And I've got 1, 2, 3, 4, 5, 6.